Good day everyone. Today I will discuss about the concepts, principles, and practices of nuclear power plant and ocean thermal energy conversion systems. So first, what is nuclear power plant? A nuclear power plant or NPP is a thermal power station in which the heat source is a nuclear reactor and is atypical of thermal power stations. Heat is used to generate steam that drives a steam turbine connected to a generator that produces electricity. So, concepts and principles of nuclear power plant. Nuclear fission. Nuclear fission is a process in which the nucleus of a heavy atom splits into smaller fragments, releasing a large amount of energy. Heat generation. The heat generated by nuclear fission is transferred to a coolant, typically water, which absorbs the thermal energy. Heat generation. The absorbed heat is used to produce steam from water, increasing its temperature and pressure. Control systems. Sophisticated control systems, including control rods, feedback mechanisms, maintain the reactor at a stable temperature by regulating the rate of fission reactions. And lastly, cooling systems. Cooling systems, such as water or gas, remove excess heat from the reactor core to prevent overheating. Next is the practices of nuclear power plants. First is the safety measures. Nuclear power plants incorporate safety features like emergency cooling systems, redundant control systems, and containment structures to prevent accidents. Next is the waste management. Nuclear power plants generate both low-level and high-level radioactive waste. Next is the regulatory compliance. NPPs adhere to regulations set by nuclear regulatory agencies to ensure the safety and compliance with environmental standards. And lastly, security measures. It is necessary to have a strict access controls, surveillance, and security measures are in place to prevent unauthorized access and safeguard against the potential threats. Ocean Thermal Energy Conversion System. Ocean Thermal Energy Conversion System, or the OTEC, is a technology for generating renewable energy that uses the temperature differential between the deep, cold, and relatively warmer surface waters of the ocean to generate baseload electricity. So its concept and principles. OTEC utilizes the temperature difference between the warm surface seawater and the cold deep seawater to generate power. Next is the working fluid. A working fluid with a low boiling point, like ammonia, is chosen to efficiently capture the heat from the warm surface water. Next is the power generation. The vaporized working fluid is used to drive a turbine, which is connected to an electrical generator to produce electricity. And lastly, condensation. The vapor is then condensed back into a liquid state using cold deep sea water and completing the OTEC cycle. Its practices. System types. OTEC uses three system types, namely open cycle, closed cycle, and hybrid systems. Next is the environmental impact. OTEC systems have a relatively low environmental impact compared to some other energy sources. However, potential impacts on marine ecosystems and local environments must be carefully evaluated and mitigated. Next is the site selection. OTEC systems require specific oceanographic conditions, including steep temperature gradient, influencing site selection. Next is the materials and corrosion resistance. Seawater exposure necessitates the use of materials and coatings resistant to corrosion. And lastly, the economic viability. OTEC's initial capital cost, operational cost, and the availability of sustainable sites influence the economic feasibility of OTEC systems. And lastly, understanding these concepts and practices is essential for the safe and efficient operation for both nuclear power plants and ocean thermal energy conversion systems. The selection of each technology should consider a balance between energy needs, environmental impact, and economic feasibility. And that's all about my video, and thank you and God bless.